question. So if you take the first A part will be like this. But 1ene is like this. Okay. Now if you are trying to, okay, and one more thing, that this carbon will have one hydrogen, this carbon will have two hydrogens attached with itself. Now when we are using hot concentrated, we break this bond. Okay. After that, I know when we have one carbon on this side and it has two hydrogens with it, it will form carbon dioxide and water according to our notes. Okay. But for this side, we have to look whether this carbon had any hydrogens or not. Okay, if it had one hydrogen, it will form carboxylic acid. If it had none hydrogens, then it will form a ketone. Okay, remember these things. So this carbon will form carboxylic acid, and we did got the propanoic acid in our first answer. Clear? Okay. Yeah. Yes. Yes. If it is on the edge, the double bond, if it has only one carbon on the other side, then it will always form carbon dioxide and water. Okay. So if I let's look into the second option, that is butene, which means on the middle we have the double bond. Okay, now if we are breaking this bond, I know that this will have hydrogen, one hydrogen according to the valencies, right? And this will have one hydrogen. So when you are breaking these two bonds, they both will form carboxylic acid. Okay, this side will also form carboxylic acid, but these are which type? These are ethanoic acids, not propanoic. Same for the C part, propene, and you have two methyl on it. Now when you are breaking this bond, this side will form carbon dioxide and water. But on the other this side, if I look closely, this will have none hydrogen because all its four bonds are completed. Okay, four valencies are already occupied, four bonds are completed. So when this carbon has none hydrogen, this will form a ketone here. Clear? That is whole the concept. Okay, for the second one, what was your answer? Let me just show. D. Okay, again let me just paste it here. Ethene reacts with aqueous Br2. We did wrote this equation. If you remember, two products were being formed. That was, one had both Br with it, and one had one Br and one OH attached to it. So which statement is correct? Both products are obtained by nucleophilic substitution. No. Both products are obtained by nucleophilic addition. Not correct. Both can be hydrolyzed to form same organic product. We don't know because we have not studied it yet. Both products can form hydrogen bonds with water. We have to see for hydrogen bonds, two conditions you should remember. Okay, one is that these three elements, one of these three elements must be present. Phon means fluorine, oxygen and nitrogen must be present in that organic compound, in that any compound, and also hydrogen should be attached with that any of these phon. Okay, so I can only see that the second compound has oxygen and hydrogen attached to it. It will form hydrogen bonds, but this compound will not form hydrogen bonds because it does not have any these two conditions. These two conditions, both conditions must be fulfilled to form hydrogen bonds. Okay, so D is also incorrect. C is the correct answer, because both products can be hydrolyzed means that you are removing the sort of Br. If you remove Br and Br from it, hydrolyze means that you are breaking, okay, a compound using water. We will be looking into this reaction, sort of elimination reaction. So the Br get removed, you get ethene. If you remove Br and OH, again you get ethene. So you're getting the same organic compound by hydrolyzing. Okay, clear? Yeah, polarity could be there, but polarity usually relates to the sort of permanent dipole. If they had asked you for hydrogen bonds with water, you must see these two conditions. These two conditions, if they are being satisfied, then only that compound can form hydrogen bonds. Else, it will never form hydrogen bonds. Okay. Let me just move it a bit upwards. Yes. Yeah, yeah, I'm recording it. Okay, try to solve these two questions. Okay, within 10 minutes. Okay, try to solve them. Yes. Two positive can be made. Okay. So according to Markovnikov's rule, we have one hydrogen here and none hydrogen on this carbon. Okay. So we need to decide where to, you know, we have hydrogen bromide, right? HBr. So where to attach this hydrogen to which carbon? So you are saying that we should attach the carbon to this carbon, okay? Because according to Markovnikov's rule, what we learned that always attach the carbon which has already more hydrogens, and the Br will be attached to this carbon, okay? So they are asking you to find out the intermediate that is on the middle part. In the middle part, the hydrogen is already placed. Okay, it is already attached. The Br is left. So it will be something like this, that carbon. This will become the carbocation, and on this carbon we have attached our hydrogen, incoming hydrogen. Clear? So we have not attached the Br yet. Okay, Br will be attached in the final state. Intermediate state, only hydrogen is placed there. So then draw the skeletal formula. Fourth carbon chain is like this. You have plus and like methyl group here. It will be A. Okay. Mm-hmm. Yeah. So always we need to form the stable product, which is a stable, like tertiary is the most stable, then secondary and is on the second, and primary is the least stable, right? So tertiary is the, so tertiary is the most stable, but we always, according to Markovnikov's rule, you will always form a stable, okay? In this scenario, this carbocation is what? This carbocation is tertiary. So you have formed a stable carbocation. Okay. So in on the whole, you will form a stable product. Clear? If I have done the opposite thing, if I have added the hydrogen on the first carbon, then you can visualize that we would be have formed a secondary carbocation, and that is least stable. Okay. For that, you always have to remember that if I have carbocation, suppose this carbon, okay, this will apply to all our incoming chapters, that is halogen alkenes, alcohols. You will always see their primary halogen or secondary, tertiary, and then you have primary alcohol, tertiary alcohol, and so on. So primary carbocation is the one which has two hydrogens already attached to it, okay, and it has only one carbon group, or it could be any carbon chain, but it has only one attached to it, okay, the alkyl chain, you can say the alkyl chain. Secondary carbocation always have two alkyl chains and one hydrogen attached to itself. And tertiary, then I think you got the idea, will have three carbon alkyl chains attached to it and none hydrogen. Clear? This is primary, this is secondary, this is tertiary. So always it is our aim, according to Markovnikov's rule, to form a tertiary or form a most stable product. Okay, for the second one, again you have to apply the same concept. Again you have to apply the same Markovnikov's rule. Look at the two carbons that are attached in a double bond and see which has more hydrogen. Attach the hydrogen, incoming hydrogen, to that carbon and Br to the other carbon. Mm, B. So this carbon had one hydrogen, this carbon had none. So you attached, okay, it is correct. So for the second, you have attached Br on the second one. Okay. Moving on to the next question. Okay, we can do this one. This one and this one. Okay, done. C. For 34, um, okay, you have to look closely in the carbon chain. Okay, first you have to discard the options which are already incorrect. Okay, how do we like recognize it? By counting the carbons. Okay, the final product has how many carbons? One, 2, 3, 4, 5, 6, 7. Right? So in A and B, how many carbons are there? 6, 7, 8. Right? So A and B are already incorrect. We don't have to look into them. Okay, because carbons won't be increasing, right? So look into C and D. If I break C, okay, what do I get on the both sides? This carbon will have none hydrogens. This carbon has one hydrogen, right? So it will form carboxylic acid. It will form ketone. Okay, and I can see that in our final product. For the D, again do the same thing. This has one hydrogen. It is also correct. It is also forming one ketone, one carboxylic. So if both are correct, which is the correct one? That we will have to look into the chain. Okay, now figure out where this methyl is placed near the ketone one. Okay, it is placed at the ketone carbon, so it has to be C. Okay, we can see, yeah, it will be on the C. Okay, you got it? That is how we're going to solve the questions. Yeah, 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 it can form any mixture of products. Okay, depending on which carbon has hydrogens or not. No, no, there's not. You just have to figure out, identify the functional group. Okay, whether the ketone will be formed of carboxylic acid or it will form carbon dioxide and water. Only these three possibilities will be there. Okay, now what? Now we have changed the conditions. We have used cold dilute acidified KMnO4, which means the magnate ions. Okay, always remember, sometimes examiner is using only the magnate ions, MnO4 minus ions in the question, because K is only used to make this compound. Okay, we cannot use the ions directly. Okay, so we attached any metal with it to form the reaction. Okay, else potassium does not have any use, okay, as such important use in the whole reaction. We only need the oxygens for from the oxidizing agent that will be using in the reaction. Clear? And one more thing, sometimes it is also written bracket, sorry, it is a slash on one side and it is written H plus. This denotes acidified. Okay, that you are acidifying the magnate ions. So when we used cold dilute KMnO4 ions, then what happens? Identify the product. Okay, so always first you have to remember what I have written in the notes, that whenever you react cold dilute KMnO4, what happens that all the double bonds are replaced with OH on each side of carbon. Okay, so it will just form OH and OH on each carbon double bonds. This product is for the hot concentrated acidified KMnO4. Clear? Yeah. Sorry. Yeah, it is a diol. It is a diol, or we can say it is a very big compound, so it won't be a diol. It is a, there's a 5 OH in it. So there are many OH in it. Diol only has 2 OH in it. Yeah, yeah, you basically break the compound. Okay, so like we can see, they have broken down the compound in C. This is a another product, this is another product, and this side is another product. We can see here. But in when you're using cold dilute, then it only adds OH on each side of the carbon double bond. Clear? Okay, again this one, try to solve it first. Remove any option that you think is wrong already, but I don't think so. The carbons are, I think, correctly written here. Try to solve it. Okay, done. D. So if we look closely into this one, if I broke this with here, and it will form, okay, it could be from A and B, okay, because on one side we have a ketone and on the other side we have a carboxylic acid. So that is could only be formed in A and B. And if we look closely into the, now we have to compare this side, right? So for that you have told me, okay, but now we need to form another ketone here, right? So for ketone, if I opt this one, it will form, because this carbon will have one hydrogen with it. Okay, this side will, this side will always form the carbon dioxide water. But A would be the correct answer if you look closely, because when we break it down from here, this will form a ketone and this carbon will form carbon dioxide and water. Clear? Yes. Mm-hmm. Yes. Okay. So you just have to, somewhat imagine it, that they are doing what they are, making it in the half the double bond, and they are spreading the chain. Okay. It is only always a matter of, I can, cannot perform the visualization here, obviously, but this carbon was actually attached here, okay, with this carbon. They were both attached to form a single ring structure. And when they did the, hot concentrated, and they ruptured the double bond, so this double bond, always just you have to always follow my steps that I have told you. Okay, look into the carbons. This carbon will have no hydrogen, the first one. Okay, so it will form a ketone. We can see a ketone here. This carbon has one hydrogen attached to it according to the lines, right? I always count the lines. It has three lines, so one line is left, that is will be a hydrogen. So if this has had a hydrogen, this will form a carboxylic acid. Both are then spreaded out to form a straight chain. And for this one, if I again rupture this bond, this will have only carbon, no hydrogen. This will form a ketone. Okay, this carbon will be separated and it will form a carbon dioxide and water. We can clearly see this in this compound. Okay, there is a ketone that is formed here, and that, the alkyl chain is still attached here. Try practicing it, then you'll get used to it. Okay, but you have to practice the questions. Now this one, uh, these are two. Okay, so you have to solve both. 8 to 9:30, 9:30 to 11:30. Yes. Yeah, on both side and two different. Okay, it is B, correct. And what about 43? Yeah, because if we have, alkenes, so we usually convert it into a polymer by breaking down the pi bond and forming this is a sigma bond that is formed within that carbon chain and all that. Okay. We can do which one? The product of this treated with. Okay, not this one. Okay, these two questions. Answer is B. And what about 48? Yes. What we have added in it? Hydroxy groups, because if you are reacting, you have two OH groups, right? You add two OH groups. So two OH groups I think equal to 34. So we must have used cold dilute MnO4 ions. Okay. try this one. Yes. Hmm. Okay. Yes. So it would be yes. Yeah, because we can, obviously we cannot take the partial monomers. We have to take it as a whole monomer. So it is approximately 10,000, not fixed 10,000. Okay. Now we have completed the P1. Now let's move on to P2. The file is at okay. Now we will be doing this question. Okay, so you have added OH on both sides. Okay, correct. And what's the second one you have done? Okay, both will form ketones on either side. Okay, sorry. Yeah, your drawing is correct. Um, or if you want to improve it further, you can do it as like you can move the CH3 on this side, CH3 on the above, and you can add OH on this side. Okay, mostly in marking schemes you would be seeing the functional group. When you are adding any functional group, you are adding it on the downward side like this. Okay, and for the second one, it is correct. Yeah, I would not say that it is not correct. You have drawn it correctly. Okay, you have just shifted the double bond, but that doesn't matter. The product is correct. Moving on to this one. Here you have to draw the mechanism of electrophilic addition. Okay, remember all the what is written here that you have to draw all the curly arrows, lone pairs, charges, everything should be there. So how do we solve it? The partial, okay, one more thing. The partial charges are already drawn here. They won't be drawn every time, okay? It is not necessary that they will be drawn here every time in every in every question. Sometimes they also include here and partial charges. Okay, so you have to draw it by yourself in some cases. So remember you have two arrows. One arrow comes from the double bond and towards this positive partial charge, and then one arrow comes from the middle of this bond and towards this negative Br partial. Okay, now you have to decide where to place the Br, the incoming Br. So it is quite easy, both are on the same. So I will just add, okay, see they have also included the new functional group here. I will add the Br on this first one. The second one will become what? The carbocation. And you have the, okay, just place the groups here. Okay, now you have the one Br left, that it will be negative along with its lone pair. Now you have to draw an arrow from the lone pair towards this carbocation, and then the Br will be formed. Okay, this is the whole mechanism that you have to practice and draw it. Okay, explain the origin of dipole on bromine molecule. How the bromine molecule got its dipoles? Because it is a non-polar, right? The Br is a non-polar, but how it got the dipole? Due to when we brought it closer to the double bond, carbon double bond, it got the dipoles induced in it. So we write it like dipoles got induced. Sorry, your voice is too low. Yeah, that is an instantaneous and induced dipole basically, because that is a sort of temporary dipole that we have induced in it, and that is induced by whom? By the carbon double bond, because carbon double bond has high electron density area. Okay, so when the Br is brought closer, initially Br has the lone pair on this side, right, on the middle, but as you move closer, the electrons are repelled, okay, because there are electrons here and these electrons get repelled, so they move closer to the other bromine on the other side. So this bromine get partial positive and this bromine get partial negative. Partial means that they are not fully separated from each other, but they are about to get separated. Okay. So what I was reading, dipole induced when Br2 brought closer to carbon double bond. J is formed. What is J that we have formed above? Equimolar mixture of isomers. Okay, state the type of isomerism shown by J. Okay, which type of isomer is J exhibiting? Cis trans. Cis trans is always when you have double bond, carbon double bond. We can see a chiral in this chiral carbon. Okay, so it will be in optical. Remember, stereoisomers has two types, cis trans and optical. Now you have to draw the structure of the two isomers of J. So first we will draw a mirror in between. Okay, this will be your chiral carbon. So what we can do is first draw the 3D structure like this. Now this dotted line will be reflected here. Like this. Now you just have to place the functional groups that were present. CH2OH, CH3Br, CH2OH, CH3Br. So this will be placed here. So you can CH2 will be reflected like this, but OH will be here, because if you reflect the OH, then the meaning of that functional group gets changed. Okay, so never reflect the functional group, you can reflect the carbon chain. And this will be H3C. Okay, Br will be like a Br, we cannot change the alphabets. And the last one was C has CH3, two CH3s and Br with it. So you can just draw it. Okay, it is optional, it is not necessary to reflect each and every functional group or each and every carbon chain. So these are two image and reflections of each other. Clear? Yeah, it is the only way. You're talking about, these chains that we have attached, the groups that we have attached. You can switch the groups in between, but tetrahedral structure will be always be like this. Furthermore, in marketing scheme, I saw that they have expanded this structure as well. Okay, you can do that as well. It is an optional thing. Okay, so in next class we will be doing some more questions of alkenes, and then um, we will move on to next we have halogenal alkanes, that is really important, so we will be doing that. Okay, one more thing I need to ask you, are you free tomorrow, like earlier, at around could be before 12 my time, 12 PST. You have a class at 11 because I have to go somewhere, so I thought we should do the class because we already have one class compensatory that is left. So if you have one class at 11 a.m., we can. Okay, next Monday at what time? Okay, do confirm me the timing, else we have to do it tomorrow before 11 if that is okay. Okay. Okay, bye.